Hello everybody, Namaskar. In the previous lectures I have discussed the basic component or main component of the vapor compression refrigeration system. So and also the different type of heat exchangers apart from that. Okay, so the main component means the condenser, evaporator or any other heat exchanger, and also the compressor and the expansion devices. Now in this lecture I will discuss some other component which are used in the vapor compression refrigeration systems. Okay, so here I have listed the auxiliary devices or auxiliary component of the vapor compression refrigeration system. There may be some other components are there, so the most of the components I have tried to listed here, which are the auxiliary component of the refrigeration system. So first one is the accumulator and separator. So this accumulator separator is not always used for all the system, but some system that separator or accumulator is there. Then the receiver, this is also used by some system. Then oil separator, this is also used by some system. So if you use the miscible oil, so for that case that separate oil circuit is not required, but in case of immiscible refrigerant, for that case the separate oil circuit is required. So for that case the oil separator, oil pump, that is required for the recirculation of the oil into the compressor. Similarly, the strainer, dryer, check valve, solenoid valve, deep first controller, connecting pipes, safety valve, side glass and moisture indicators. So these are some auxiliary devices which are used in the vapor compression refrigeration systems. So if you see this figure, so this figure I have tried to represent a complete vapor compression evaporation system which can contain all the devices. Okay, all the devices, all the auxiliary devices are there. So I have tried to use all the auxiliary devices in the refrigeration system apart from the main component like the evaporator, expansion device, compressor and the condenser. So apart from these four important components, the other component are also there in this figure which is used in this refrigeration system. So you can see that the oil separator, that is used after the compressor to separate oil from the refrigerant flow. So at the outlet of the compressor the oil is mixed with the refrigerant, and in the oil separator the oil is separating, then only the refrigerant that is going to the condenser. Okay, so then after the condenser we can use the receiver. So receiver that is basically the container, liquid container, act as a liquid container, so that can store the liquid after the condenser, and we can also maintain some outlet flow of the liquid refrigerant after the receiver. So the receiver also used to control the system or mass flow rate to the system. So I will discuss in details. Then there is a filter or dryer. So filter is basically used to filter the unusual component or some solid particle if that is mixed with the refrigerant. Okay, so that we have to filter. And dryer is basically used to dry up the refrigerant. That means if there is any moisture which has been mixed with the refrigerant, so the dryer is basically the absorb all the moisture which is there in the refrigerant. Okay. So after that you will see that we can use some valve which can be used to control the mass flow rate to the circuit. And apart from this you can see that before the compressor and after the evaporator we have the suction accumulator is used. So this suction accumulator is basically stored the refrigerant after the evaporator, and this will be confirmed to flow only the refrigerant vapor after this, which can be flow to the compressor. Okay, so and some regulating valves and are there, and for this case maybe different type of expansion devices we have already discussed, but for this case this is the thermostatic expansion device is used for this case, where the bulb that is connected at the outlet of the evaporator, which will control the superheat after the evaporator. Okay, so now we can briefly discuss each component which I have listed in the previous slides. Okay, so and before that, this is also another diagram. This is basically used for the domestic refrigeration system. Okay, so for the domestic refrigerator, you can see that the outlet portion, that is basically the evaporator. Okay, outlet portion is basically evaporator section A, and this component B, this is basically the condenser. So this condenser is the back side of the refrigerator, and this evaporator is basically the deep section. Okay, deep section of the refrigerator, or deep cabin, or the cold cabin, upper cabin of the refrigerator. And apart from this, you can see that some other component like the C is represent the compressor. Okay, so similarly the H is represent the motor and the electrical connection. Similarly, K is basically the main electrical supply for this system. And apart from this, the D, this is basically the capillary tube expansion devices. And apart from this, other component like the J, this is the filter dryer. Okay, so then apart from this, G is basically the door switch, and F is basically the interior light. Okay, and E is basically the thermostat, so or cold control. So for this case, basically thermostat, that will basically indicate the inside temperature of the refrigerator, and based on that inside temperature of the refrigerator, the system can be on or off. Okay, system can be on or off. So by this way, the capacity of the system can be changed, but because we are using the capillary tube, so this is the fixed restriction type. So for this case, mass flow rate cannot be changed. Okay, but we can on off the system to control or to control the overall output from this system. Okay, refrigerator. So this is the general layout of a household refrigerator. So now we will discuss one by one component. So one component, very important component, that is the accumulator. Okay, so the main function of the accumulator to catch and hold the unused portion of the system charge, and it protect the compressor from the liquid slagging. Okay, so after the evaporator, as shown in figure, that after the evaporator, this refrigerant is coming to this separator or accumulator. So it at any condition, if the outlet of the evaporator is the two-phase zone, that means the liquid and vapor. So obviously this system can be stored, this accumulator can store that liquid in this system, so that liquid cannot be go to the compressor. So that means if you directly connect the outlet of the evaporator to the compressor, then anyhow if the evaporator outlet is in a two phase, so that means the liquid will also go to the compressor. But if we use this accumulator in between that, so we can prevent the liquid refrigerant to go to the compressor. Okay, so for this case, basically the outlet of the evaporator, this is connected with this, and outlet refrigerant that is coming in this chamber. So from this chamber we have to make the arrangement by this way that only the that vapor from the accumulator that will go to the compressor. Okay, so that means the extra liquid that will be stored in this case, and in any case if the outlet condition is superheated, so for that case the liquid refrigerant that will evaporate and that will be mixed with that, so that the that more refrigerant that will be go into the compressor. Okay, So this accumulator also, that accumulator is basically the when the excess for low load condition there is an unused portion of charge that will be stored in this, and for the high load condition that is will be again used for the refrigeration application. Okay. So then another component is called the receiver. So the one figure is there, okay, for the some company to show the how the receiver is how like a receiver or how the receiver looks like. Okay, so for this case also this is receiver is basically used after the condenser. So after the condenser, that the condensed refrigerant, that means the liquid refrigerant, that we can directly connect it with the receiver. Okay, so that receiver, the outlet of the evaporator condenser, that will go to the receiver. So in the receiver, that is basically a storage device, okay, or storage container. So that refrigerant will be stored in the receiver. Then as per our requirement, we can take out the refrigerant from the receiver. Okay, so that means in case of if we use the valve, expansion valve or manual expansion valve after the receiver, then as per our requirement, we can get the higher flow rate when needed and the lower flow rate when needed. So the outlet or the mass flow rate to the expansion devices, that can be controlled as per our requirement, and excess refrigerant that will be stored in this receiver after the condenser, or maybe if the extra refrigerant is required, that we can take out. So that means this receiver also can be used to store the refrigerant after the evaporator. So this is one type of storage devices, and if as per our requirement, we can change the refrigerant outlet, okay, outlet refrigerant quantity we can change as per our requirement after the receiver. Okay, so receiver and the accumulator, both are basically storage devices, but in the accumulator on another function also we can do, that is we can confirm that the inlet of the compressor, that should be always the vapor. Okay, so that condition is also confirmed by using the accumulator. Okay, so then there is a oil separator. So I have already told that some refrigerant which is not miscible with the lubricant or the oil. So for that case, we need a oil separator after the compression process. So after the compressor, the refrigerant will go to the oil separator. So in the oil separator, basically one inlet and there is two outlet. Okay, so after the compressor, that will going to this oil separator, then that oil and refrigerant, that will be separated out. So one side we will get the oil and another side we will get the refrigerant. So after that, this pure refrigerant, that will be going to the other component like condenser, and the oil that is separating out from the oil separator, that is again going to the compressor by using a oil pump. Okay, so then the other component, that is called the strainer. So strainer is basically filtered. So this is used to filtration of the contaminant, okay, in the refrigeration system. So any unnecessary particle or any type of particle, any type of unused component, or some let's say that maybe something the particle from the construction material. So if this type of particles are there with the refrigerant, so that can be filtered by using the strainer. So a strainer is basically used to filter the solid contaminants. Okay, so then another device that is also very essential, that is used to remove the moisture. Okay, so we can use, so that is called the dryer. So dryer is used to remove the moisture or absorb the moisture from the refrigerant. So when the refrigerant is flowing to this dryer, then we will use some material inside this dryer which can absorb the moisture. Okay, so that material will absorb the moisture for the refrigerant. So the refrigerant outlet condition, that will be the pure refrigerant, that means the moisture free refrigerant we can get outside of this diode. Okay, so in general for the refrigeration system, that the strainer and dryer both we can make a single component. Okay, so that means we can use a single component which is called the dryer, filter dryer, which can basically use to remove both the solid contaminants and also the moisture from the refrigerant. Okay, so most of the cases in general this is used as a combined device or a combined component. Then another is your check valve and solenoid valve. Okay, so these are basically the flow control valve. So the check valve, this is a part of controlling the flow direction of a refrigerant in the refrigeration system. So it is self automated and prevent the reverse flow and avoid the reduction of cooling efficiency of the system when the compressor is stopped. Okay, so that means if the compressor is stopped, so the refrigerant after the compressor, that may be trying to go reverse direction to the compressor, but if you use the check valve after the compressor, so that check valve that will prevent the refrigerant flow in a reverse direction from the condenser to compressor. Okay. Similarly, other type of valve, that is called the solenoid valve. This is also used to control the flow. Okay, so but for this case, this is basically the electromechanically controlled devices. So this is frequently used to control the flow of liquid or gases, and this function is simply to turn the refrigerant flow on or off. So this valve actually controlled by the electrically to perform the on off. Okay, this is a on off valve. So at any condition, this check valve is also on off valve, one type of on off valve. So if you use this valve, and any time we can get on or off of the flow. Okay, so this is also one type of a flow control valve. Then another is the safety valve. So safety valve is sometime this is generally used for the safety purpose. So that means for any circumstance, if the system pressure that is lower than the design pressure or the lower than the safe pressure, or maybe the system pressure is higher than the safe pressure, so that time this safety valve can be used to block the system or the close the system or block the refrigerant flow through this safety valve. Okay, so sometime we can use to depressurize this safety valve. So this safety valve can be used to safe operation for the high pressure side and safe operation for the low pressure side. So in case of high pressure side, if you use the safety valve, so this is the high pressure control or high pressure safety valve, and that may be the low pressure safety valve. Okay, so if the pressure is higher than the allowable pressure or safe pressure, that is also dangerous situation. If the pressure is lower than the design condition or the safe condition, that is also dangerous situation. So what is happening, that let's say if the pressure is higher than the that safe pressure, so that means pressure will be very high. So there may be chance of the breakdown of the system or blasting of the system. So that's why for this condition, this safety valve is basically depressurize this system. So some cases we can use the secondary line, so that the extra refrigerant that can be coming out from this through this safety valve, so the high pressure that will be again lowered. Okay. Similarly, in case of low pressure also there is a problem. If the pressure is very low, that means that system will be working at a negative pressure, and the evaporator temperature that will be also reduced. So for that case, there may be chance of any leakage from the outside to inside, and the outlet air will be coming into the system, and the moisture is there, that moisture will form the ice. So that type of problem will be occurs inside the system. So that is also not desired undesirable conditions. So that's why for the safety purpose, the lower side also we have to use some safety valve, which is basically the stop the system if the pressure is lower than some that pre-decided pressure or some safe pressure of the system. Okay, so for the high side and low side, both sides safety valves are required to safe operation of the refrigeration system. Then defrost system. So for defrost system, I have already discussed in the lecture related to the evaporator that the in case of evaporator, the most of the time we have to maintain the temperature that is lower than the 0 degree centigrade. Okay, so for this case, what is happening that the moisture in the air that will form the ice, or that will frost. Okay, so that ice that will be block the passage. Okay, so that and block the system, and sometime that ice will be formed. You can see in the household refrigerator, the ice will be formed in that zone, and that ice will be make a layer on the evaporator. Okay, so that ice will be basically create some extra resistance for the evaporator heat exchanger, so that evaporator heat transfer. So that's why the ice formation on the evaporator tube or ice formation on the evaporator plate, whatever may be, so that will create extra resistance for the heat transfer, so that will degrade the performance of the evaporator. And another thing is that in case of the fin tube type or fin tube type evaporator, where there is airflow and air is flowing in between the fins. Okay, so for that case, that channels are very narrow. Okay, so if the ice will form and if the ice will block that passage, narrow channel for the airflow, so that will block the airflow also. So that will also degrade the performance of the system. So that's why in a certain period or the periodically we have to defrost the system. That means all the ice which is deposited on the evaporator, that ice we have to remove. Okay, so that's why we have to use some defrost system for that application, and the different type of defrosting methods that I have already discussed. Okay, then the last one is the connecting tube. So we have to see the compatibility of the refrigerant with the connecting tube, and based on that we have to decide the suitable connecting material or connecting tube for the certain refrigerant or refrigeration system. So the steel or copper or aluminum are generally used as a connecting tube material for the most of the refrigeration systems. Okay, thank you.